This is Module M5E of the Indiana DOT Certified Asphalt Lab Technician Program, and it deals with the calculation of asphalt mixture volumetric properties. Now that we have run the tests to measure maximum specific gravity, GMM, and bulk specific gravity of the compacted mix, GMB, we have the information that we need in order to calculate air voids. So air voids is equal to 100 times the maximum specific gravity minus the bulk specific gravity of the compacted specimen divided by the maximum specific gravity. So in this particular case, if the GMB of the compacted specimen is 2.290 and the maximum specific gravity is 2.428, to calculate air voids, we would calculate air voids by taking 100 times 2.428 minus 2.290 divided by 2.428, and we would get an answer of 5.7%. So let's look at an example where we have some extraneous information and the information that we need in order to calculate air voids. So remember, we only need two different things. We need the bulk specific gravity of the compacted specimens and the maximum specific gravity. And we see that the bulk is 2.316 and the maximum is 2.426. So air voids is maximum minus the bulk of the compacted specimen divided by a maximum. So it's 2.426 minus 2.316 divided by 2.426, and the air voids is 4.5%. So let's look at this example. We have the maximum specific gravity of the mix, the asphalt content, the bulk specific gravity of the mix. Well, we only need two different things, the maximum and the bulk. So the air voids is going to be equal to 100 times 2.443 minus 2.284 divided by 2.443, and it calculates out to be 6.5%. So that's air voids, calculation of air voids. The next thing we will deal with is the calculation of VMA. So VMA is 100 minus the bulk specific gravity of the compacted mix, GMB, times the percent of aggregate, or the percent of stone, PS, divided by the bulk specific gravity of the stone, which is GSB, standing for gravity of the stone bulk. So in this example here, if we are given values of 2.290 for the bulk specific gravity of the mixture and 2.519 for the bulk specific gravity of the aggregate, and 94.5% for the percent of stone, and we plug the numbers in, 2.290 times 94.5 divided by 2.514, all of that minused away from 100 leaves 13.9%. So the VMA in this example is 13.9%. So what about this example? Okay, we've got some information here. We've got the asphalt content, the bulk specific gravity of the aggregate, the air voids, the bulk specific gravity of the mix, and the percent passing the number 200. So what do I need? Well, I need the bulk-specific gravity of the mix, so that's a compacted specimen. I need the percent stone. Okay, where does percent stone come from? It's not given, but anything that is not asphalt binder is stone. So therefore, the percentage of stone, or the percentage of aggregate, is 100 minus the asphalt content. I am given the asphalt content, 4.5%. So 100 minus 4.5% of aggregate is 95.5. So now I have all the information that I need, the bulk specific gravity of the mix, percent of aggregate or percent of stone, and the bulk specific gravity of the aggregate, GSB. And I plug these numbers in and I get 14.3%. Okay, now it's our turn. So what do I need? I need the bulk specific gravity of the compacted mix. I need the bulk specific gravity of the aggregate, and I need the percent of aggregate. Once again, percent of aggregate is not something that is normally given, so I have to calculate it by knowing the asphalt content. Do I have the asphalt content? Yes, I do. It is right there. So the percent of stone is going to be, or the percent of aggregate is 100 minus the 6.1, which is going to be 93.9. And I have the bulk specific gravity of the compacted mix, and I have the bulk specific gravity of the aggregate. So I have all the pieces of information that I need. I don't need air voids. I don't even know what asphalt index is, but I don't need it. So now, if I plug these numbers in, I get the bulk specific gravity of the mix times 93.9 divided by the bulk specific gravity of the aggregate, 2.599. All of that taken away from 100 gives me 15.6%. So my VMA is 15.6%. The next thing for us to calculate is the voids filled with asphalt. So if you think about the space between the compacted aggregates, that is the VMA, which we just calculated in the last slide, and you think that VMA is composed, or that space between the compacted aggregates is composed of asphalt binder and air, two different things. So percentage-wise of that space that is filled with asphalt, how much is it? Well, I only need to know two things. I need to know the VMA and the air voids. So if I take the VMA minus the air voids divided by the VMA, times that by 100 to make it into a percentage. And in this example, the VMA is 15.6. The air voids 5.5, 15.6 minus 5.5 divided by 15.6, multiply it by 100, and I get 65%. So the VFA, voids filled with asphalt, is 65%. Okay, here's an example for us to work on. So to do VFA, I need to know two things. I need to know VMA and air voids. I have more information than what I need. I don't need the bulk specific gravity of the aggregate. I do need the VMA, 13.6. I don't need the bulk specific gravity of the compacted mix. I don't need the asphalt content. I do need the air voids, and it's there. So it'd be 13.6 minus the 4.0. So VMA is minus the air voids divided by VMA, which is 13.6, minus 4.0 divided by 13.6 times 100 is 71%. And so the last thing that we will calculate is something that is referred to as the binder replacement. That is the total percentage of asphalt binder that is in our mixture. What portion of it comes from recycled materials? Now, there's two possible sources of recycled materials. One is RAP, reclaimed asphalt pavement. The second one is shingles, reclaimed asphalt shingles or recycled asphalt shingles. So RAP and RAS. Now, I need to know the percentage of RAP and the percentage of RAS in my mixture. I also need to know what the asphalt content is of those recycled materials. So the binder content of the RAP and the binder content of the RAS. And then, of course, I need to know the total asphalt binder in my mixture. So how do we calculate that? So here is an example. We've got the percent of RAP is 15%. The percent of shingles is 3%. The asphalt content of the RAP is 4.0. The asphalt content of the shingles is 20.0. And the total asphalt content in my sample is 4.8%. So if I take 0.04, which is 4% expressed as a decimal, times 15%, which is 0.15 expressed as a decimal, and the asphalt content of the shingles, 0.2, which is 20% expressed as a decimal, times 3% shingles, which is 0.03 expressed as a decimal, and divide that by 0.048, which is the the total asphalt content expressed as a decimal. Multiply that by 100, I get 25.0%. So my asphalt binder replacement in this mixture is 25%. And that's the end of the presentation.